Okay. So this is Bhaskar, having 14 plus years of IT experience. I'm working for one of the Indian-based company. I'm having experience with Microsoft Business Intelligence. Actually, my career was started with the SSIS, and I adopted all the stack of MSBI, and later I got an opportunity to work for Microsoft. And there I work for Data Factory and Databricks, and even currently I'm working for Microsoft Fabric. Yeah, so this is orally about me, and we are going to see as part of this demo, we are going to start talking about Azure Data Engineering. So, what is this Azure Data Engineering? Why we need to go for Azure Data Engineering? The term is saying here is data. So, it is used to process the data. So, data engineering is the process of processing of your data. So why we need to process the data, that I'm going to give some brief idea about it. And previously we were called as ETL developers, and ETL developers now are treated as a data engineers. So data engineering is there in many places. We have it in Azure, we have it in GCP, we have it in AWS. So the market is having more demand from the Microsoft Azure, and Azure Data Engineering is the topmost engineering services that we are having in the market. So let me give some brief idea about why we need to go for data processing. So data processing was there even before data engineering, before Hadoop. Okay, so how it was there and why we need to go for that, let's see. Let's take an example. Most of us are aware of how we can order a product from Amazon or Flipkart or any banking application or anything. You know how we can make a transaction. If you take an example of Amazon, customers are going to use that application to order the product. When the customer is going to order the product, definitely they're going to provide the product details. Product details are required. And in order to deliver the product, location details are required. I mean, the customer is going to provide the location details while ordering. And the payment mode, the payment details are also is going to be provided by customer, and at these orders are going to be placed at some point of time, so date and time will be there. So like this, there are many dimensions or many aspects are going to be happen for every transaction. So once these details are provided by customer, and those details are going to be captured by appropriate business. So Amazon is going to capture all those details, and they're going to keep in the database, because we required all these details in order to deliver, in order to handle, and in order to analyze the business also. So because of that reason, we capture all those details of the transactions, and we're going to keep the data in the database. So this is how, if you take any typical business, every business is going to be happen in the similar approach. Okay, so we are not going to be part of this application, but after this, we are going to be part of it. After this, our journey is going to start. This application running and maintaining of all these things will be taken care by application developers. Maybe Java applications, .NET application, or there may be something which may be they may use in order to run this business application. But our journey is going to start right after your storage, right after their storage, we are going to do it. So why the people are going to take the data from this database, why business is expecting is to get the insights on top of the business. So in order to get the insights on top of the business, we need to, because whatever the data is there here, it is going to be completely raw data. The way the business was designed is not suitable for analyzing the business. So it is specifically designed for running of the business. You cannot understand, or you cannot consolidate the data, because you will be having hundreds of tables here, and there will be relationships. Many things are going to be there. But this system is not capable enough in order to start doing an analysis. So here is a place a data engineer comes into the picture. As I said, before data engineering, we were used to process the data as a ETL developers. Even I started my career with as a ETL developer from Microsoft SQL Server Integration Services. So like this, there were many other ETL tools like Informatica is there, or Data Stage is there. So there may be some other ETL tools were there. Before 2 decades ago, we were more familiar with these services. Of course, now many changes happen. I'll tell you that. So in the olden days, we used to take the data from the business systems in order to provide the shaping of your data, in order to provide the cleansed data to the business. We need to take the data from the business systems. So business system means this system I'm taking as a business system here, because our journey is going to start from here. Our journey is going to start right from the business system. So just imagine I have a multiple databases as a business systems. All the systems are having my day-to-day transactions or my business transaction data as part of this business system. So wherever you are going to keep the data for your business, so that particular system, we can call it as a OLTP system. So in interview, there is a chances to ask, what is the difference between OLTP system and OLAP system? Because the basics also is important for understanding the warehousing concepts. So this system is an online transactional processing system, which is specifically designed for running of the business. Your application is going to talk directly to this business system. And as we are going to be, as we are ETL developers previously, I used to, even most of us used to provide the data to the business system or business after processing. So I used SSIS previously, and by using SSIS, we can extract the data from the various systems, do apply transformation as per the business requirement, and then we can load the data into the target. So mostly the target is for OLAP system that is used to call as a data warehouse. So data warehouse is specifically designed for analyzing the business. I wanted to expand my business across the different products and different regions. If you wanted to do that, then definitely you need to understand what is happening in the business. So that kind of analysis is required by the business. Okay, so reporting team is ready to create a report for the business, but who will provide the data to the reporting team? So to the reporting team, we are going to provide the data. As a ETL developer or as a data engineer, we are going to be responsible to provide the data to the reporting team, and we are responsible to provide the data to the data scientist team also. Okay, so we are going to talk about it. So this is OLAP system, means online analytical processing system. You'll be having a less number of tables when you compare with your business system. So this is going to have a facts and dimensions. But here, no facts and dimensions. We are going to have a master tables and detail tables or transaction tables. So many tables are going to be there here. The way it is designed for business running, but the way we designed here for analyzing the business here. So it's a traditional approach. This is there even now, but the way of doing a processing from the business system to here is completely changed. Many changes happen in the market. Okay, so that point of time when I worked with SSIS, that was not supposed to do data processing if I have a varieties of the data. So a decade ago, the mobiles was introduced, right? So the data got completely changed. We got semi-structured data, we got unstructured data. So varieties of the data was introduced. But that point of time, these particular tools, the traditional ETL tools, were used to process only structured data. We were not able to process semi-structured data. We were not able to process unstructured data also. So there are many limitations are there. The disadvantages with the traditional approach of your data processing is the major disadvantages are data processing. If you have a varieties of the data, your traditional systems are not capable enough to process the data. That is one very major issue. Another major issue is storage. The storage also was a problem. If you're not, if these systems are not enough capable enough to store the data, then definitely we look forward. Okay, so we faced an issue for data processing and we faced an issue for data storage also. So because of that reason, that particular problems, these problems, we used to call them as a big data. Big data was introduced. Big data is going to have a varieties of the data, and big data is going to have a massive volume of data. So ultimately, you're not able to store it. If your system, let's take an example of your laptop, if it is allowing to store 500 GB to store, but my requirement is to store 501 GB, then your system is not capable enough to store the data because it is exceeded your storage. So that kind of problems were there in the traditional approach. So to provide the solution for your big data, the Hadoop came into the picture. The Hadoop came into market to provide the solution for your big data. Observe here, a big data means a data that cannot be stored inside your system, or if your system is not capable enough to store the data, that particular data will be treated as a big data. Or if your system is not capable enough to process that particular data, so that data also will be treated as a big data. So that is what I'm just giving a simple definition. The data which is not possible to store or which is not possible to process, that data we can treat as a big data. As simple as that. So in terms of Gmail, we cannot attach more than 25 MB. Okay, subject to correction if they changed anything. But as per my knowledge, more than 25 MB, if it is there, then it is not going to allow you to attach. Attachments cannot be done. So that means this 25 MB is a big data for Gmail perspective. And for your company, maybe 500 GB is a big data for you. But if you go for Facebook, there is a TBs of the data is going to be generated on every day. So depends on their platform, depends on their system. We can say is that a big data or normal data. So normal data may be big data for you. Or like if you take a Facebook or anything, they are going to process TBs of the data. So that data is very huge volume that even you cannot process with your systems. Maybe you have to increase it. But anyway, I just wanted to say for a data that is not possible to store or process, so that data we can say it is a big data. So I mean to say these traditional systems are not capable enough to process or to process your big data. It's not able to do it. Because of that reason, we look forward and the Hadoop came into picture. Hadoop came into the market to provide the solution for your big data. The same source systems we are going to use, the same source systems can be used for your Hadoop also. Hadoop is used to extract the data and transforms the data because there is a map reduce. Let's say Hadoop. Hadoop is having two components. One is map reduce. Before that, let's say HDFS, and second is MapReduce. So we are not going to talk about what is HDFS, what is MapReduce, and how we can do it. It's a traditional now. Okay, so that point of time I'm saying before decade ago, this was set trends in the market, and many projects were migrated towards to the Hadoop to handle the big data. So HDFS is going to provide a storage solution, a distributed file system, Hadoop distributed file system. How this distribution of the file is going to be happen, we'll see in our journey. That is ADLS Gen 2. We are going to talk about it as part of Azure so that you can understand how data is going to be distributed. And this is for storage they provided because I told there are two problems for your data or for your big data. One is storage problem, another is processing problem. So processing can be done by your MapReduce. But the problems here, there are also here also we have a multiple problems. I'll talk about it. So we can store the data in the warehouse and we can, I mean, the reporting team will take the data from here, data scientist team will take the data from here. That is how it is going to be happen. So when the Hadoop was a good solution for your big data, then why we came out of Hadoop? So then you need to understand the disadvantages of your Hadoop. So you can understand like how this journey was happened in terms of data processing. Advantages are there. Advantages is we can store massive volume of data and we can store varieties of the data. That means we can store structured data, we can store semi-structured data, and we can store unstructured data. And we can also do the data processing parallelly because the data is going to be stored in the cluster. I'll talk about what is a cluster. The data is going to be stored in the cluster and data also is going to be processed in the cluster. So because of that reason, we can read parallelly and we can write parallelly. Or simply I can say we can do data processing parallelly. But when you go for the traditional approach, here no cluster. It's a single system, monolithic system, no distribution. But whereas here in the Hadoop, we're going to have a distributed processing. So in simple way to understand, let's take an example. I have some work. I wanted to finish this work by a single person. If I take this one, you just imagine it is going to take some 5 days to complete the work with a single person. In the same way, for same work, I'm going to give it to 5 persons. If I give the same work to 5 persons, then definitely it is going to take only 1 day. Because that is going to be possible only in the Hadoop. If you go for traditional approach, the previously like traditional ETL tools, that was not capable enough. Because of that reason, we look forward towards Hadoop. So Hadoop is going to store the data in each mission. If I have a 5 node cluster, so 5 node cluster means 5 systems. The data is going to be distributed across all the 5 systems and the data is going to be processed across all the 5 systems. So it is going to be faster. And these systems are not is not huge configuration. They are commodity systems, the cheaper systems. But here you need to have a like a supercomputer kind of, because if you wanted to process it with a single system, that's highly impossible if you go with the normal configuration. But here you can have a normal configuration, all together is going to work, and they're going to share the data, they're going to process the data. So that is the beauty of your Hadoop. Then what are the disadvantages then to come out of this Hadoop? The disadvantages is, in order to process the data, we need to write too many lines of the code, too many lines. And you just to try for any chat GPT or anywhere, just for word count, you can see you have to write more than hundreds of lines, more than 100 lines, I'm sure. You can just try. I'm not much aware of it, but I know it is going to take too many lines of the code. Okay, so that is one problem. When you write too many lines of the code, then definitely the delivery of the product is going to take longer time. So ultimately, that impacts the business also. If you're taking longer time to process and give the insights to the business, and they have to analyze it, they have to take the decision. So by the time many things are going to be happened in the business. So that means we cannot deliver the product on time. That is one more problem. And when you go for Hadoop, 100% should be known about Java. Java should be known. Otherwise, we cannot do it because the code you're going to write in a Java. So later, many ecosystems came into the picture on top of your Hadoop. Okay, so Hive came, HBase, Pig came. So many ecosystems are there. I'm sorry. So in order to process the data with the Hadoop ecosystems, you need to spend a lot of time with the different services also. Okay, it's not a single system. To simplify this, they brought with a different kind of systems on top of your Hadoop. Okay, so there are many problems are there. You have to learn many things and you have to spend a lot of time to write the code. It's really difficult for the people who were already having experience on ETL, and this is much more easier for Java developers, but they're not going to be aware of ETL concepts, how this types of dimensions and how the dimensional modeling works. So this kind of lack of knowledge will be there both vice versa when you compare with ETL developers and Java developers. Okay, so that is a part of your Hadoop. And again, we came out of this Hadoop because it is on-prem completely. So you need to have your own cluster. Run and maintenance is very huge. Okay, so many problems are there. And to say the big data, we can have a three ways the characteristics of your big data. In simply, I told like if you are not able to store the data in your system, that data will be treated as a big data. So that definition is going to be based on this characteristics of your three ways. One is volume, variety, and velocity. So if you have a huge volume of data, then that we can say it is a big data. So the big data of the data of your I mean big data of your business maybe is a small data for others. Okay, it's a depends on the system configuration. We can say is that big data or not.